Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to go through nuclear power plants. What we'll be covering in this video is about how nuclear power plants generate electricity, as well as the components in a nuclear power plant and their functions. This is a topic in the SPM physics syllabus. There's always a lot more to know. So if you'd like to find out more about this topic, please feel free to do your own research or watch my other educational videos. What I'll be covering in this video is just the general information that you would need to be able to answer the questions in your examinations. So let's begin. This is a schematic diagram of what a nuclear power plant looks like. This is taken from the KSSM textbook, so this may look familiar, and you can actually refer to your textbook while watching this video. Let me move my face out of the way over here so that we can take a look at what's going on here. So on the left-hand side here, this is where the magic happens. In number 1, the reactor here, this is the nuclear reactor where the nuclear fission reaction happens. So the uranium rods are placed inside here and they're controlled with boron control rods. So what's going on in the reactor here is the nuclear fission reaction takes place. If you can't remember what's nuclear fission, please watch my video on nuclear fission. So here we've got the neutrons that move around, striking the uranium atoms, producing nuclear energy, and of course the nuclear fission products. These control rods are used to control the reaction that takes place. So the boron control rods here can be moved up and down using a robot. So if we want more reaction, the rods are lifted so the neutrons can strike the uranium atoms easily. And to decrease the reaction, we push the boron control rods down to block the neutrons from striking the uranium rods. So what's going on in here is that the nuclear fission produces nuclear energy in the form of heat energy. We have water flowing around here. The water will absorb the heat, becoming very hot water. And this hot water is then channeled through these pipes over to the heat exchange system. The heat exchange system here, there's two main parts. We've got water being pumped in from the right and the water coming in from the left. So coming in from the left is very hot water. On the right, it's, well, water that's not so hot. So the heat exchange here takes place from inside the pipe to outside. The water on the outside part will absorb the heat and becomes so hot it boils and becomes steam. The steam travels up, goes through the pipes here, and then the steam will spin the turbine. So this is a steam turbine that is connected to a generator to generate electricity. Now, once the steam turns the turbine, it loses energy because the heat energy, which becomes kinetic energy, now it's lost kinetic energy, it becomes colder, losing its heat energy. It will condense back into water, and then it will be channeled back into the heat exchange system, repeating this process all over again. So this system here is just to transfer the heat energy to the outside because we need to cool the water down enough so that the water that gets pumped in here is cold enough to be able to absorb the heat effectively. If the water pumped in here is still hot, it can't absorb the heat. So this is the cooling system. Another set of pipes, as you can see. So there's another heat exchange going on here. So the water inside the pipes here will absorb the heat from the water on the outside. So the water flows inside the pipe here and are taken outside to the environment, released so that the heat is left and escaping out to the environment. So that's why we've got a cooling tower over here. So this is the general flowchart to show how the nuclear power plant works in terms of energy generation. So first of all, nuclear fission of uranium-235 and its chain reaction produces heat energy. Water is then pumped into the reactor core, which is a nuclear reactor, to absorb the heat energy produced by the nuclear fission. And then in the heat exchange system, the water that's being pumped inside will absorb the heat from the water from the nuclear reactor, and this causes the water to boil, producing high pressure steam, which is then channeled to the turbine. The turbine is then rotated by high pressure steam, which then rotates a magnet or coil in the generator, and the steam will condense into water. The electrical energy generated is then sent to consumers via a power supply transmission system. So if you can't remember how the generator works and if you can't remember the transmission system, please watch my video on generators as well as the electrical transmission grid. So here's a quick reminder of nuclear fission. Let me put my face here. So nuclear fission is when a large uranium atom was struck by a neutron, causing that uranium atom to split into two smaller nuclei and producing additional neutrons as a product. So if you can't remember nuclear fission, here's a quick summary. So nuclear fission is when a larger nucleus, in this case uranium-235, is struck by a neutron, causing the uranium atom to split into two smaller nuclei as well as two or three additional neutrons. So generally, what's going on in the nuclear reactor is this. So as mentioned, we have the control rods, which is usually made of boron or cadmium. So the more common one is boron. So that's why in most cases, we just call it the boron control rod. But yes, they can also be made out of cadmium. So it controls the reaction rate by absorbing the excess neutrons. These rods can be controlled to move up or down. The moderator, which is here lining the uranium rods, they will slow down the fast-moving neutrons to allow nuclear fission to occur. So the neutrons have to move, but they cannot be moving too fast, because if it's too fast, it will just glance off the uranium atom instead of producing the nuclear fission reaction. So while the neutrons need to move, they cannot be too fast. Cannot be too slow either, but cannot be too fast. So that's why it's used to slow down the neutrons. So the moderator is normally made out of materials such as graphite or water. The main source of energy here, of course, is the uranium rods. So the uranium rods are the fuels used to produce nuclear energy through nuclear fission reaction. Now, the safety features that must be put in place, because as we all know, uranium is highly radioactive and radioactive material can be quite dangerous to living cells. So the safety features here, number one, it has to have thick concrete walls to prevent radioactive radiation from leaking into the surroundings. So if you recall, concrete can reduce gamma radiation provided that it's thick enough. That's why very thick concrete walls. Yes, the energy produced here by the uranium are usually alpha and gamma radiation. There's a lot of energy that could also be produced, and if we don't control the energy, it can cause an explosion. So that's why we have to use a cooling agent, in this case water. So water absorbs the heat energy from the chain reactions to generate steam in order to control the reactor temperature. If we don't control the temperature, an explosion can occur. And this is how some of the nuclear power plants have exploded in the past. For example, the Chernobyl disaster. You can, of course, read up about it or watch some documentaries on it. But generally, what happened is that there was too much energy produced and the boron control rods were not pushed down to control the energy. And as a result, due to too much energy produced, it caused an explosion, causing uranium to be released into the air as dust. And yes, that area is quite highly radioactive, even until now. And that's it. So, if you found this video educational and helpful, please click like and subscribe for more lessons, solutions, and exam strategies from your physics teacher, Miss Ho. Happy studying!